So I was looking at cryptocurrency values online and they were all changing here, there and everywhere as I was watching it, and it looked kind of cool, and it got me sort of thinking, wouldn't it be cool if we could somehow use this kind of change and movement on the values of cryptocurrency in some way to sort of generate voltages to sort of power analog synthesizers. Ooh. So I basically needed to figure out a way of getting these values off the internet and sort of transferring them into some way, getting voltages to go and play out into analog oscillators and this, that and the other. And it sort of dawned on me kind of early on that I probably wasn't the right person for this, because yeah, I'm not very codely endowed, and you know, like Raspberry Pis and ESPs and stuff like that. And my name, as it suggests, well, yeah, I'm a little bit useless at this sort of stuff. So I figured it was probably best, instead of going like this for a couple of weeks or so, I should reach out and ask if anybody wanted to give us a hand. So I sent out a tweet, and Stephanie Explains It All replied. If you've been following the YouTubers Secret Santas, you would have seen that I've already made a cat piano that somewhat didn't work very well, and her cats didn't really like it. Well, to be honest, my cat didn't like it either. But without much haste, after finding out she was up for giving this a go, I gave her a quick call. You know how crypto stock market is always quite up and down? Basically making a synthesizer module that is basically voltages of the like top 6, you know.
I love this.
It's a pretty dodgy idea, but as far as I know, I think they update every 30 seconds, but I don't know where I read it, because I might be pulling that out of my...
Today I did a 12-hour hackathon, and I think we got what we needed, right, Luna? Yeah?
After this chat, we bounced back and forth for a couple of days, and she also has a video about this project over on her channel that is more focused on the coding side of things. So if you're interested in that, I'm not going to go very deep at all into that stuff, so go and check out her video on that stuff. But like most seemingly straightforward projects, yeah, there was a couple of problems.
Oh, I tested Google and Ethereum only, and I thought it was done.
Yeah.
And it turned out that Google doesn't show any other coin, and I had to start over and do it with Yahoo Finance the next day. So that took me another 3 hours.
But after a few days, she mustered up a plan using a Raspberry Pi and sending out pulse width modulation signals, which can be filtered down into analog voltages, which thankfully was a heck of a lot simpler than my suggestion to her, which was using digital to analog converters. So phew. She showed me her breadboard setup, which had 10 cryptocurrency values being portrayed on LEDs, with just a simple resistor and capacitor between the LED and the Raspberry Pi pin. These pins were sending out voltages that were correlating to the percentage of change that certain cryptocurrency was experiencing at that certain moment in time. And wiring this up and hearing the note change for the very first time was pretty awesome.
Hey! Yes! I've been a plonker.
Hey! Yes! I've not gone into a massive amount of detail about this because Stephanie has explained it all. Stephanie explains it all. Anyway, it was now time to take what Stephanie has done and add the analog components to it to make it into an analog synthesizer musical machine. So this right here is the prototype. This has got some slide functions to it. Ethereum just changed. I've got this wired straight into Ethereum. This is a buffer board that's pretty much just a buffer, a slide circuit, and then another buffer output. They don't update at the same time, so they can change chords. So I think it can make quite thick chords if we wire in all of these voltages into oscillators, for instance. So at this point, I didn't really know how this thing was going to turn out, but I figured the only way of kind of figuring out if this thing was going to sound any good or not was just to keep on going and keep on making circuits, because right now we're only listening to one cryptocurrency at any one point going ooh. So I went ahead and built 10 of these buffering, boosting, sliding circuits on some spare perf board that I had sitting around. So here we go, here's 10 of those buffer boards. So what it is it's the power supplies on the top, this is the input, this is the output, and then there's a little LED on each of them. And then I've also got the Raspberry Pi. Well, there's the Raspberry Pi, and then there's the pulse width modulation converters that you add. And then there's literally just some analog circuits that pretty much really slow down the changes, so it goes like whee.
And this would be a great tool to know when to sell and when to buy.
Yeah.
Because I've noticed how they all start going down or when they all start going up all at the same time.
Yeah.
In between I see like little fluctuations. I was doing like with my multimeter checking the voltages.
Yeah.
And it's still kind of small.
So what Stephanie was talking about there was the fact that, you know, if there's a steady period for a certain value on a crypto coin thingamajiggy, well, the voltage isn't going to change much. Raspberry Pi sends out 0 to 3.3 volts, so she was measuring it between there and noticing that the voltage change was quite small. And other times there's been quite large changes where the actual voltage change is quite big. So there's quite a large scope of changes and how these voltages may interact with each other. This is the great thing about the way it's done, is the output from the Raspberry Pis, their resolution is quite high, so you can really kind of dial in and get some really small voltage changes, which means in theory when we get 10 analog oscillators wired into this thing, hopefully, fingers crossed, we'll get some really weird interactions between them, because we'll be getting all of these microtonal changes within the chords and the notes. You won't be hearing like proper perfect notes and stuff. You'll be hearing tiny bends and slight little beats between the oscillators, like when it'll be let's keep on going anyway. So after getting to this point, I still hadn't actually really got a grasp on how much it was changing. So I shot this time lapse to just double check I wasn't going mad and it was actually doing something. This is about 4 times as quick. I've been looking at these lights, they move around, so I'm pretty sure it's working. Very excited to see what comes out, to be honest. Very excited. Oh, how do you spell Ethereum? M. Snip. Boom. So now it's time to make some analog synthesizer oscillator voice things. I went for a really simplistic approach with this because all I really needed was something that kind of complemented the output of the buffer, which was about 0 to 10 volts. So I ended up going for a sine wave VCO that was directly pulled from the LM13700 datasheet. It's just one side of an LM13700 chip to make an oscillator that is voltage controlled. It's basically just an oscillator that's made from one side of an LM13700. So a change, we'll be able to make 2 oscillators out of this single TLO72 and this. The cool thing is it's a really high resolution to the voltage, so you're not getting perfect tones, you're getting all of the microtones in between, and that's the great thing about doing it with pulse width modulation instead of firing it over MIDI and stuff. It makes it a lot easier to get the notes within the notes. So after breadboarding these oscillators, I made 5 of these on perf boards and put them in the enclosure as well. I got a little bit carried away and forgot to film some of this, though you'll see some close-ups in a little bit of them anyway. But you'll see that, yeah, I basically just put some volume knobs on top for every single oscillator as well, and after that it was pretty much done. Woo! So here it is, this iteration is done. I did it over the space of a couple of days, and yes, I am already thinking of a number of improvements for it, but it really kind of shows a proof of concept, and it is really a nice installation piece, to be honest. On the front are just volume levels for each of the cryptocurrencies, so the listener can isolate certain parts. This is going to be in the museum of everything else, and I guess I'm going to put some wall mount headphones onto it because this running constantly might be a bit hard. But it is a stereo machine, so it is pretty captivating in headphones. So just after I finished this, I recorded an hour-long sort of segment of it doing its thing, and that is available to watch if you want. The links are below. But looking at this little hour-long snippet of the crypto values on a Saturday afternoon, bear in mind, yeah, it's pretty cool. We had a good range of different things. There were a lot of parts where they were literally just slightly, the voltages were just slightly changing, which caused the beating within all of the frequencies just to kind of of change a little bit and just get a little bit weird. And then there was moments where like all of them seemed to just go down. And then there was bits where some of them went up and some of them went down. It's, you know, it's a Saturday, so there's probably not much going on, but like imagine listening to something like a really bad crash at one point with this thing. It will just be like, it will never play the same thing twice, and you cannot predict this kind of stuff unless you're a predictor of this kind of jiff jaff, which I am not. I'm absolutely useless at this stuff. So like, yeah, you can just sit and listen to the live performance. Imagine this as sort of a listening device. The song that it is playing, well, it isn't playing a song, it's listening to a song that is being spanned out over many, many years since the start of this whole cryptocurrency thing. And then this is just merely listening into clips of that. So it's something that's constantly moving, changing and evolving with an outside input, and you just have no control. You are not the composer here. If you want it to get more interesting, well, you cannot. You're gonna have to just wait for a load of things to start changing and moving. You may say it is a little bit slower, but this is just a realistic representation of the input that it is receiving. If you want to see more of what is happening on the Raspberry Pi, definitely go and check out Stephanie's YouTube video. That is up now, the link is below. If you want to watch the hour-long video, then definitely check it out as well. And also if you want to support the creation of these videos and these machines, which will also end up in the Museum of Everything Else, so you can come and play on these, and in this instance sort of listen, which will be open pretty damn sure by the end of the month, so you can literally come and try this by the end of the month. Well, please go and check out over on my Patreon. There is also a high definition WAV download of the hour-long performance of this over there, so you can just download it and listen to it. It's quite nice to have in the background, I've got to be honest. I'm also going to be doing a live stream in the next week or so where I'm going to be writing all the new patrons' names on the knobs around the museum, because I've definitely got quite a bit of catching up to do with that, because I've got the 1000 oscillator mega drone to finish off, and I've got a load of other things. So if you want your name on a knob in the museum, then go and check out over on Patreon. Any tier, you'll get your name on a knob. Oh dear. Anyway, that's the end of this one. This is the cryptocurrency synthesizer. I'm Luke, I'm no computer. If you like this kind of stuff, don't forget to subscribe. And yeah, maybe don't try this one, but don't be scared to try it. But maybe try this one if you like it. It's actually not that bad, is it?